Hey guys, I made 10 really tough FRQ questions for you to try. If you can get all 10 right, you're going to be ready for your AP Econ exam. Pause the video when the question appears, solve it on your own, and then resume and see if you got it right. Make sure you stick around till the end because I threw in a bonus question too. Good luck. Okay, pause the video, give number 1 a shot. All right, let's do it. So what makes this hard is that it is an increasing cost industry. When firms are attracted to this profit here, you're going to see supply shift outwards. But unlike a constant cost industry, these increasing cost industries mean there's more competition for resources, which drives up the marginal cost and average total cost for firms in the industry. That's very different from a constant cost industry. Now, that means profit's going to go away just like in a constant cost industry, but price doesn't actually fall by as much as in a constant cost industry. There's P2, it's just barely shifted down. And then that's really kind of because supply doesn't shift by as much, S2. A little supply shift, but quantity for this firm actually falls by more than in a constant cost industry. This would have been the quantity for a constant cost industry here. And for the increasing cost industry, it's here. But notice price did not fall by as much. It would have been down here for the constant cost industry. Profitability is the same for both. They earn zero economic profit in the long run. Tough question. Okay, number 2. Pause the video. Go try it. All right, let's do it. So the answer to the question is the consumers are going to pay the tax. And the reason is because demand is perfectly inelastic. That means it's a vertical line, and supply is just a normal elastic or relatively elastic line. When there is a tax applied, let's call that S sub T for tax, you're going to see that the price is going to go way up. And because consumers are insensitive to price, maybe this is something like insulin where you have to have it to live if you're diabetic, they're going to bear all of the tax. That means this whole tax revenue or tax burden is going to be put on consumers. Tough question. 3, terms of trade. Pause the video, go try it. Okay, let's do it. So who's got a comparative advantage in cars? Real quick, that's going to be the United States because they give up only 1 boat to make a car rather than Canada, who would give up 3 boats. And then therefore, Canada's got a comparative advantage in boats because they only give up 1/3 of a car rather than the United States, which gives up a whole car. But the question is about terms of trade. Here's the trick. Look at one good and compare the 2 countries in terms of opportunity cost. Their domestic opportunity costs are 3 and 1. Any number between these 2 numbers is going to be an acceptable terms of trade for both countries. So what's a number between 3 and 1? How about 2? That'll work. Okay, number 4, elasticity. Give it a shot. Pause the video. All right, let's do it. So don't get confused. This is not price elasticity of supply. We're looking at cross price elasticity of demand. Even though they're producers, the question's about a producer, it's about a factory, we still want to use percentage change in quantity of X divided by the percentage change in price of Y. Now, quantity only changed by 5, price changed by 20%, that's way more. We end up with a positive number of 0.25. If you were calculating cross price elasticity of demand and your result is positive, they must be substitutes. If they were negative, they'd be complements. Cool. All right, number 5. Pause the video, give it a shot. Watch out for that long run. Okay, let's do it. So, real quick, long run, monopolistic competition. Maybe it's a cafe, right? They can only earn normal profit. That means you want to do your ATC here tangent to the price at the profit maximizing quantity, which is of course at MR equals MC up until you hit the demand curve. To go through deadweight loss, producer and consumer surplus, remember, deadweight loss is always going to be a triangle that's pointed at the allocative efficient point or the socially optimal point, and here it is right here. This is what society wants. They're not getting it because of maybe a lack of competition in the market, so there's your triangle. Consumer surplus is up here. It's always from the price up until you hit demand curve. Producer surplus is from price down until you hit the marginal cost curve, which remember is basically a supply curve as long as we're above AVC. But it's sort of right boundary here, or its X value boundary, is where it hits that dead weight loss because this quantity over here is not being supplied. Okay. All right, number 6. Perfect price discrimination. Pause the video, give it a shot. Okay, let's try it. So first I graphed a normal monopoly. This is not a perfectly priced discriminator yet. I want to show you that they are not allocatively efficient for a normal monopoly. So they are producing where MR equals MC and then going up until they hit the demand curve because MR and demand are different curves. So here is their price. And notice, this is not where marginal cost is at. Marginal cost is way down here. So a regular monopoly is not allocatively efficient, but something's different for a perfect price discriminator. Marginal revenue is no longer here. It is now equal to demand. That means the amount that they produce is going to be way bigger. It is now here where marginal revenue equals marginal cost. And at that point, we also have marginal cost equals price. So there's your new one. So quantity for the price discriminating monopoly, right? And now because marginal revenue equals marginal cost here, price is equal to marginal cost. That's price for the perfect price discriminating monopoly. And we do have allocative efficiency, even though it's a monopoly. That's pretty cool. Okay, next question. Cool. Number 7 asks about natural monopoly. Pause the video, give it a shot. Okay, let's do it. So natural monopolies. These incur decreasing average total costs along that demand curve, right? Decreasing average total costs. That's because we kind of want only one firm producing this good because they can do so at the lowest cost because of economies of scale. To graph these, make sure MC crosses ATC kind of to the right or outside this demand curve. Now, profit maximizing quantity, that's easy. MR equals MC. That'll show you the quantity that they maximize profit at. The price is up here, of course. Revenue maximizing quantity, this is a little trickier. How do you know where this maximum total revenue curve hits its local maximum? It's wherever marginal revenue goes negative, because if they made one more output, marginal revenue would be negative. That means total revenue gets pulled down. This curve can also kind of show you, based on its intersection with the demand curve, where the elastic range of the demand curve is. That's up and to the left along the demand curve. And down and to the right shows you the inelastic range because, remember the total revenue test, increasing total revenue, elastic. Decreasing total revenue, inelastic. The socially optimal quantity, this occurs where marginal cost meets demand, right? That's how much society wants. That's your allocatively efficient quantity as well. The break-even point, that's where total costs are equal to total revenue, or rather average total revenue, and you can find that here. So ATC equals price at this point here. That's your break-even point. ATC equals price. So unregulated, break-even, socially optimal. Cool. Next question. All right, number 8, game theory, Nash equilibrium. Pause the video, give it a shot. All right, let's go through it. So dominant strategies. If Dwight discounts, what should Jim do? Open or close? Close. If Dwight is normal, what should Jim do? Open or close? Open. Jim does not have a dominant strategy. Does Dwight? Let's find out. If Jim opens, what should Dwight do? Discount or go normal? Well, he'd go normal. If Jim closes, what should Dwight do? Discount or normal? Discount. That means Dwight also does not have a dominant strategy. Now, for Nash equilibrium, we actually end up, after you check all the equilibriums, with 2 Nash equilibriums. In both of these outcomes, neither player has an incentive to change strategy given information about the other players, pay off some profits. So, 2 Nash equilibrium, no dominant strategies. Okay, next question. Cool. Number 9, market failure, negative externality. Pause the video, give it a shot. All right, so great example of a negative externality is smoking, both because of secondhand smoke, but really a bigger one is that smokers cause a lot of increase in insurance premiums because they get sick way more often. They need a lot more medical care, so everybody's insurance costs are higher because some people choose to smoke. That means that the marginal social cost is way higher than the marginal private cost to the firms that are producing cigarettes. So the societal cost, price for society, is really high, and what society actually wants is way less smoking quantity of socially optimal. How do we fix this? How do we get supply to shift in such that it's equal to marginal social cost? We need to use a tax, but what kind of tax? Is it per unit or lump sum? The answer is per unit. Lump sum only affects profitability because it'll get applied to fixed costs. Per unit affects output. Every unit you make, you're going to be taxed on. That's actually going to reduce output and eliminate the externality. Cool. Next question. All right, number 10 has a monopsony graph in it, maybe the toughest graph in all of micro. Pause it, give it a shot. Okay, let's go through this. So, things to notice on your monopsony graph. MRC, or MFC, it's the same thing, does not equal the supply of labor. It's above it. That means they can pay people less money and they're going to hire fewer workers. Now, minimum wages in competitive markets are a bad idea. They cause unemployment, but in a monopsony, they're a good idea. Here's why. When you put in the minimum wage, it causes MFC to track along that minimum wage all the way until you see supply of labor exceeding the minimum wage. That means that once we get to that point, MFC then jumps way up high, up to here. And we're going to increase the amount of labor that we hire because MFC now meets MRP here. So Q2, that's more workers we're going to hire, and we're going to pay them more money. That's very different from a competitive labor market. Okay, time for the bonus question. Overtime, utility maximization. You got your budget, your prices, pause the video, answer the question, how much are we going to buy? Okay. Let's go through this. So I always tell my students, anytime you get a table like that, you're probably going to need to add more columns to it. Where we really want to end up is at this mu of x over p of x and mu of y over p of y. That's marginal utility of x divided by the price of x. The way you do that, because we're given total utility here, just the change in utility from quantity of 1 to quantity of 2 will give you the marginal utility, right? So the marginal utility of the first good is 24. The second good, from 24 to 40, would be 16, right? And now, to get to mu of x over p of x, just divide that number by the price. I put the prices here for x and here for y. This is what we end up with. 8, 4, 6, 2, and 1.5, right? And then 6, 3, 2, 1. Okay, time to spend our money. What do we want to spend our first, dollars on? Is it x or y? Well, it's x, and the reason is because 8 is bigger than 6. We're getting more marginal utility per dollar spent by buying some x. How much did it cost us to get that x? $4. So we no longer have $24. We're down to 20. I like to keep a running total there. How do we want to spend our next money? Well, we can either spend it on y and get 6 or x and get 4. In this case, hey, we want to get 6. That's great. How much did it cost us to get that 6? Well, that's going to cost us $3. So how much do we have left? 17. So on and so forth. What do we want to spend our money on next? 4. How much did that cost us? $4. How much do we have left? 13. What do we want to spend it on next? 3. How much did that cost us? Well, one good y costs $3, so we're down to $10. $10. How do we spend our next money? Here we're actually it doesn't really matter, right? Because they're both giving us 2. I like to think, though, I'd buy the cheaper thing. So let's go with another of y. How much did that cost us? Cost us $3, so we're down to $7. Up next, we're going to buy an x because 2 is bigger than 1. Let's buy another one of those. And finally, that cost us $4, by the way. So we are now down to $3. So how do we spend our last dollars? Well, we can either choose between 1 or 1. Well, doesn't really matter, except it does. We only have $3 left. So what do we want to buy? We can't afford X, so we have to get a Y. So let's buy that final Y. That'll extinguish our budget. We're now down to $0. So how much of each should we buy? We're going to be buying 4 of good Y and 3 of good X. That's how we maximize our consumption bundle given a budget of $24. Thanks for watching. Good luck on your exam.